What's up, you guys? It's me, Abdul, and I'm back again with another episode, or tutorial in this case. It's been months full of procrastination, lots of homework. I thought that transferring schools, bad malware bites. I thought that transferring schools would allow me to have more time, and I also attended GDC, and that was another monster within itself. So, without further ado, we're going to do quite a bit today. We're going to first start off with fixing our camera script. So without further ado, let's just go to the camera script, look at this, open this up. Okay, so what we're gonna do is just delete everything. Just get rid of it. So basically with this camera script, what we want to be able to do is when the player gets close enough to the right edge of the screen, we want the camera to move and follow the player. But also when the player tries to traverse backwards, we want them to be able to stop at the current position of the left screen. The extent of the left screen. We don't want it to move to the left. That's not how the original Mario Brothers worked. It was all about restrictions and bad collisions, because the NES and Famicom had limited hardware, and they got the bang out of their buck for that. So without too much defending on Nintendo's part, what we're gonna do is create a public transform. Let me zoom in a little because you can barely see that. So we're gonna create a public transform, call this player posh, and then another public transform, and call this right cam boundary. And then we're gonna create another transform and call this level end. Okay. So, and we're going to make a vector 3 and call it destination. So what we want to do off to the start, is we want to, Visual Studio integration with Unity now is a little more beefy, is a lot beefier than it initially was, and I kind of like it, but at the same time it's kind of debugging to get used to, because sometimes I'm ahead of it in terms of like making the corrections that I know it's now going to make. But anyway, so with destination, we want this to basically, I'll explain this a bit. I want to be able to make that point to you later. So we're going to also create the private fixed update. Okay, sorry. Scroll down here, get on. You're going to make an if get rid of the insert, if vector3 dot distance player posh dot position, and our second vector will be right cam boundary dot position is less than, let's say 14 and a half. Yes, no, yes. Okay, 14 and a half. We're going to say that the transform dot position of the camera or the game object attached to the script will now be vector3 dot smooth damp. We want it to smoothly dampen towards, so its current position will be transform dot position, and its destination would be, or its target will be destination, or destination vector. We're going to have to pass in a reference value that is a type vector3 of its current velocity, and also a smooth time. So, let's see here. We're going to, in our global variables, define another vector3, call this velocity, let's set this equal to 0 initially. Right. Okay. And then here we're gonna just call reference vector 3, and this is velocity. This is its current velocity. So basically, I'll get to that in a second, explaining every bit of this. So it's current velocity, and then we're going to say the dampen, or how fast we want it to smooth, the smooth time, and then let's say the max speed, which 8.5. No, yes, no. And I'm gonna go here and yeah, that sounds fine. Because we're so zoomed in I can barely see. Maybe if I... Okay, so what this is saying, if the distance between our player's position and the right cam boundary, the position of the right cam boundary object is less than 14 excuse me, 14.5 world units, then the transform position of the camera will now begin to smoothly dampen towards the destination from its current position, and its initial velocity will be 0, and its smooth time will be nearly a 15th, and its max speed will go to 8.5 units per frame or per second, or what? I shouldn't say per frame, per fix update. Yeah, there we go. So yeah, and basically, okay, now here we're going to go back to our scene, and then we're going to do what we do best, drag our player onto our player posh, have that nice position. Our right cam boundary has yet to be created, so what we're going to do is the level start, go to our scene view, change this to 2D. The level start game object is just a collider. It's stored in the game object. We're going to duplicate this, press W, hold down shift, bring it to the right edge of the camera's view, change it to right camera boundary, and then we're going to store it as a child under the main camera object. And then what we're going to do now is the level start, simply drag it under there as well. We could call this left camera boundary, but it's yeah, let's do it. So left camera boundary. Then from here we're going to go back to our main camera, drag the right camera boundary to the right camera boundary object, and then we're going to go to the level end. So here we go, and let's say so here we're gonna, there's our level end object. Let's just move it here for a bit. Don't want it to go too far, but just for a bit, so I can show you something. So what we're gonna do is press plus, go here, and already we have some funky stuff going on. Okay, malware, you're really annoying me with these notifications. I'm not even downloading anything anymore. Those applications are closed. Calm your chiz chacks. Oh god. Okay. So firstly, you notice that we can only see, like, it's doing some weird stuff where we're only seeing our bushes, and if you look closely, like, I'm moving and it's not moving with me. So what we're gonna do here is define a couple things. So our destination has a problem. So it's not defined anything. So what I'm gonna do is, let's forget about destination for 2 seconds, because that's its own problem. But this is what I really want to show you. So let's replace destination with level end dot position. Control please. So the level end is yet to be, okay, here we go. So if I attach the level end, what it's doing now, so here's a big problem. So the level end object is right here, but, and this is specified as the, where we want the camera's position to stop. But the right camera boundary is way over the extent of our ground and is just not correctly conveyed in our level the way that we want it to. So basically what this is doing is that the center of the camera object is aligning itself, is technically the origin, or I guess you can say like the center of gravity, even though a camera doesn't have gravity, but kind of the pivot point of the camera's position. And that's due to the fact, I guess, that there's like a anchoring system similar to how the UI in Canvas has it, but the only thing that's stopping us from perfectly centering the camera's center on top of the level end position coordinates is the fact that our player is colliding with the level in game object. So if we go back to our script, basically we want the right camera boundary to align with the level in and not the center of the camera. So if we go to our start function, we want destination to equal, let's say vector3 dot clamp the magnitude, and we're going to say the magnitude of level in dot position. Correct, right? And that is going to be actually I don't know what that's going to be, because it changes every time you change the position. So what we're going to do is just, let's print that out. Print level in dot position dot magnitude. We could take the square magnitude because it's less computationally expensive, but at this rate, we're not really going for efficiency. So right off the back, if we open this up, look into our, did I save? It has nothing to find. Okay, that's weird. Okay, assign it. Okay, the current magnitude of level end is 29.19713. Okay, I don't know if you can see that, but that is basically going to be the position or the magnitude of the camera's new transformed out position when we get it there, and that's going to be centered at the center of the camera. So what we want to do is be able to offset that. So what we're going to do is say the destination, so let's say that's the case. Firstly, here, let's do something. Let's go back to our script, let's comment this out, and let's move this to the end of the level, because technically that would make it the level end. So the end of the level, hold down shift, drag it to the end. Okay. go here, back to our main camera, make sure everything's selected properly, save, go here, save, and then Control P. Okay. Now the current magnitude is 38.1731. So we're going to go back to our script, get rid of these comment lines, get rid of the print function, the print magnitude statement. We don't really need that. So, okay, if it's 38, let's do like 10 or 9 units off. So let's do like something like 9.7. I don't know. I think that's 7. 9.7. A 70th of the current value is like 38.17 if I recall correctly. So here, we're going to say, okay, we're going to clamp the magnitude of our destination between the level position, and then we're going to say that the max value that this can be is 28.8. And with that, we should get the effect that we want. So we're going to come here. It's close, but not quite. But you can see how this is reaching for... Oh, okay, I see. What we didn't do is, in line 23 where I had level in dot position, change that back to destination. That should fix it. So we're going, and it stops. And there's a little bit of leeway, and obviously, we can't see anything. Our camera's still here, and within our camera's viewing scene, we can see our player. And why is that? Well, let's look. Okay, so our main camera has, instead of a Z position of -10, it is now -2. So change that to -10. Okay, you see it. And it's going to go back to its -2 value. So basically with that, what we're going to do is, one, in the start function, after we change the magnitude, because the magnitude includes the X, Y, and Z axis, we're going to say that destination now equals new vector 3 destination dot X, keeps X value, destination dot Y, keep the Y value, but change the the Z value to -10. And from there we should be able to see, and we're going to offset this value a little bit more. So let's say 25.8. So, and this value is going to be completely arbitrary, up to you. So play with it, and that's basically just the max magnitude that it would be able to have. So let's go here. And it's a little closer, but now we can see our script. We can see our scene, we can see our player, which is a lot better. And also I'm going to change this from 14.5 to go down to 11, because it's a little too much. Like, it's the second I start moving, it starts moving too. So 28.8 the 25. Let's try 22.8. Okay, and you can see it is a little off from the edge, which is perfect, which is pretty good. You can see the level end is there, and the right camera boundary is there. So only about a couple units of space, and I think that one of my main problems is that the player is way over here. So if I was to grab the player, move them over here, I probably would not have the same problem. Yeah, I actually might want to increase that back to 14.5. So yeah, be sure to move your player to the as far left as you can. And you can see here, the player's moving, get to the far right, can't go anymore. Try to go back left, can't go anymore because of the collider. And you have some ugly little animation going on here. And also, one thing to note is that this is free aspect, so this is changing with the size of our window. So what we want to do here is change this to 16.9 will do. I'm changing mine to 16.9. You can make yours whatever you want. Granted. So we're going to take the main camera. Okay, first we have two problems here. Our left camera boundary is too far away, and our right camera boundary is too far away. And then we want our main camera to be perfectly lined up with the beginning of the level. We want our player to be pretty darn close to that same expectation. And then here we can't move. Right, we can't move. And then we're gonna go here. We're moving, we're moving, we're moving. Can't go anymore. Can't go anymore because the screen is move in transition only to the right. So it's perfect. The perfect screen that suffices. It's not perfect, but it gets the job done. So what we do there is say we're seeing.